Yeah, welcome everyone to this platform, mineral mining. We just want to look at some of the data we processed so far with the remote sensing techniques and magnetic lineament interpretation to look at some alteration zones which we inferred and actually got to the field to look at what some of the locations look like in terms of lead zinc mineralization. Remote sensing techniques actually provides meaningful information to mineral exploration by identifying some hydrothermally altered minerals and fracture and some fault system. We all know that hydrothermal alteration is a very complex processes that actually involve mineralogical, chemical, and textural changes, most of the time resulting from the interactions of hot aqueous fluid with the rocks, which they circulate and under evolving chemical conditions. So, and we know that hydrothermal alterations are actually being influenced by a number of factors, especially the temperature, the pressure, nature of host rock, wall rock composition, some fluid composition, and also fluid rock ratio can also be considered. This the spectral profile and spectral library plots that was actually carried out. This was done using some multispectral imaging of 8 bands, worldview 2 and worldview 3. This was actually analyzed and with some spectrographs obtained, which was also compared with the United States Geological Survey spectral avoidance graphs to see what it looks like. If you look at these locations, we actually detected some certain spectral reflectances match with the quartz, kaolin, and also cassiterite and barite. So this was also the case field. You can see some of the plots here, the values, again the wavelength. You can see the quartz lines, the kaolinites, and the cassiterites. We also try to look at some radiometric footprints on the locations. This is the uranium count. Actually showed a very good demarcation, a good boundary, which has some also intersection with some the lineaments in that location. And this is also the potassium thorium ratio is very high, as you can see here. We look at and to the 1D and 2D magnetic lineaments that was actually interpreted also gave a very good correlation.
To be more competent, very hard, harder than the other surrounding materials, and you can see the evidence of oxidations around it. You can see some ions, you can see different kind of colorations and all that. So definitely, and this is where they won one of the best materials, possibly they've won, a lot of products from within this location. So that's absolutely. that does it. So I think, and you can look at that quartz here. Look at the quartz here too. The quartz here. See the quartz. And you can see the sandstones. You can see the sandstones, quartz sandstones. You can see. This is telling you of kind of rapid cooling. You can see. This is the sandstone. So definitely this should be good region. If you look at there, can you zoom in there? Can you see there the kind of fault there? Can you see the faulted block? There's a faulted block around there. Look at that line. Can you get it? Where the guy is? There's a fault. Kind of can see something that looks like a fault from here.
Yeah.
So definitely this morbidity disturbed zone. So we'll have to actually check this zone with what we are seeing from satellite lineament. We'll compare them and see what it looks like. Okay, so kind of I see some prismatic faults here. You see? So actually you can see that is can see some evidence of oxidations here. Also can see some oxidations. See different kind of quartz here. Definitely see some concretions. So this is highly mineralized zone. You know, we're dealing with some contact kind of metamorphism here. You know, I think this actually corresponds to the contact zone marked from the magnetic lineament. That light sulphide. See how shiny, and you can see how well developed the sites look like. So this is the kind of thing you see here. Let's look. Have you seen any other one? Like what? Let me see. Okay, no. That's well developed course. You can see the crystal faces. 1, 2, 3, 4, 5, about 6 well developed faces. Then see clay. See another kind of clay you usually see here. Sometimes it's enveloped here. You see concretions. You see different layers. If you break this, you see, can you see layers? See the first layer, see another layer. If you break it, sometimes you see it enveloping lead. So this is the kind of, and it's heavy. It's heavy. Yep. See this? You see? Some coloration. This is very heavy. This is very heavy. This is very, very heavy. Unusually heavy. Okay, let's go. Wow. Yep. This, wow, it's interesting. It should be, this
This
can be
can be
like
like
85%.
85%.
That
That
is
is
typical.
typical.
Wait,
Wait, what I'm saying here. That's the different layers. The conclusion if the clay is housing, try to develop lead sulfide and the different kind of chambers. So that's why most of the clay here you see are very heavy. So you have to make sure that you break to see inside. That's it. So it's an interesting pattern of formation here. So Oscar, that's for you. For job well done.